Good day, kids. Welcome to School Gate. We started a topic in our last lesson, which is fraction. And we said fraction is one or more parts of a whole. And we also looked at like and unlike fractions, and we looked at numerator and denominators. We said numerator is the number above the line, while denominator is the number below the line. And we said like fractions are fractions that have the same denominators, while unlike fractions are fractions that have different denominators. So today in our lesson on fractions, we'll be looking at equivalent fraction, lesson 7. Our learning objectives: at the end of the lesson, you should be able to identify fractions that are equivalent, know how to get equivalent fractions. And instructional material will still be making use of New Method Mathematics for Primary Schools Book 3. Now this is a chart showing equivalent fractions. Before we move close to this chart, I want to tell us the definition of equivalent fraction. What do we mean by equivalent fraction? Then we come back to our chart. All right, kids, so what is equivalent fraction, or what are equivalent fractions? Equivalent fractions are fractions with different numerators and denominators. That means they have different number above and different number below that represents the same value or proportion of the whole. They are different numerators and denominators, but they represent the same value. They represent the same value of the whole. Let us go back to our chart so that we can explain what we mean by the equivalent fraction. Now we have 0 here, we have 1. We have 1 over 2 here. And we have 2 over 4 here. We have 4 over 8. Now, these two are of different denominators and different numerators and denominators. This one too, different numerators and denominators. But fractions here are equivalent fractions. They represent this whole here. Are we getting it? 3 over 4, 6 over 8. They are different numerators and denominators, different numerators and denominators, but they represent the whole number here. That means when you further divide them or multiply them with the same number, you will get this number here. Now, the next thing is, how can we get equivalent fractions? There are two methods. You can use multiplication or division. Now, by multiplication, you multiply the numerator and denominator with the same number. Multiply the numerator and the denominator with the same number. That's how you get equivalent fractions. For example, you're given 1 over 2, and you're asked to find the equivalent fraction of 1 over 2. Think of any number. Multiply the numerator, multiply the denominator with that same number. Now, we started with 2. 1 multiplied by 2 will give us 2. 2 multiplied by 2 will give us 4. That means the equivalent fraction of 1 over 2 using 2 is 2 over 4. Now, you could use another number. You could use 3. 1 times 3 will give us 3. 2 times 3 will give us 6. So we have 3 over 6. That means 1 over 2, 3 over 6 are equivalent fractions. Now, you could use multiplied by 5, multiplied by 6, but make sure that the number you use to multiply the numerator is the same number you use to multiply the denominator. Are we following, kids? Okay? Now, another method is by division. By division, you divide the numerator and the denominator by the same number, just like that of the multiplication. You multiply the numerator and the denominator with the same number. For example, if you have 18 over 24 and you want to reduce it to its equivalent fraction, you say, let's take 2 for instance, divided by 2, divided by 2. 18 divided by 2 will give us 9. That means 2 times what will give us 18. And 24 divided by 2 will give us 12. That means 2 times what will give us 24. Or you count 24 and you divide by 2. You'd have 12. That means the equivalent fraction of 18 over 24 can also be 9 over 12. If you further still divide it with 3, Get a number that can divide the numerator and the denominator without remainder. That's the only rule surrounding that of division. Make sure the number you use can divide the numerator and the denominator without remainder, okay? So 18 divided by 3, if we take 3, 18 divided by 3 will give us 6. 24 divided by 3 will give us 8. Now, if you say you want to use 4, 18 divided by 4, you will have a remainder. But 24 divided by 4 will give us 6. So you can't use 4 to divide 18 over 24. Are we following? So anytime you're asked to reduce to their equivalent fraction, if you're dividing, make sure it's the number that would divide exactly without remainder, and it should be the same number. But when you're multiplying, you multiply both the numerator and the denominator with the same numbers. Okay, let us look at these examples. What is the equivalent fraction of the following? Equivalent fraction of 3 over 6. Now you can use any number. We are making use of multiplication and we want to make use of 2. So we multiply our numerator and our denominator by 2. So 3 times 2 will give us what? 6. These are 6 here multiplied by 2 will give us 12. So the equivalent fraction of 3 over 6 can also be 6 over 12. Now you could make use of 3, you could make use of 4, okay? So just make sure that the numbers are the same. 4 over 8. Now we made use of 3 here. 4 times 3 will give us 12. 8 times 3 will give us 24. That means the equivalent fraction of 4 over 8 can also be 12 over 24. Now the question could come in another form. It could be 5 over 10 equals to 10 over dash. We are asked to find the unknown. When you're given a question like this, what you ask yourself is, how did we get 10 here? That means 5 multiplied by what will give us 10. 5 multiplied by 2. And you know this is equivalent fraction. That means if they multiply the numerator by 2, the denominator too will be multiplied by 2. Okay? So that means 5 times 2 is 10. 10 times 2 will give us 20. So the missing number here is what? 20. Are we getting it? Do we understand? Okay? Our evaluations. Let's see if we understood what we were taught today. What is the equivalent fraction of the following? 1 over 6. You can use either the multiplication or the division method. Okay? 2 over 3. Copy and complete each of the following. 1 over 2 equals to 2 over, we are asked to find the missing number here. 3 over 5 equals to unknown over 15. We are asked to find the missing number here. I'm going to give us a few minutes to do these evaluations. All right, kids, our solution. 1 over 6. Now, you can make use of any number to multiply or to divide. Make sure it's the same number. So for this, we are going to be making use of multiplication. Multiplication, okay? So we made use of 2 here. Maybe you made use of 3, you will still get the correct answer. 1 times 2 will give us 2. Then this 6 multiplied by 2 will give us 12. So even if you didn't get 2 over 12 as your answer, maybe you multiplied this by 3. Just make sure the number you used to multiply the numerator is the same number you used to multiply your denominator. So if you got your answer correct, clap for yourself. Then for 2 over 3, we made use of 3. You could make use of 4. 2 times 3 will give us 6. 3 times 3 will give us 9. So the equivalent fraction of 2 over 3 can also be 6 over 9. Perhaps you multiply this by 2. You will get 2 times 2, which is 4. 3 times 2, 6. So you could get 4 over 6 as your answer. Copy and complete each of the following. We have 1 over 2 equals to 2 over unknown. Now, our question is 1 times what will give us 2? Since we have 2 here. 1 times 2. That means we'll multiply the denominator also by what? By 2, which is 2 times 2. So our number under is what? 4. If you got 4 as your answer, clap for yourself. Then this is 3 over 5 equals to unknown over 15. Our question is 5 times what will give us 15? If you go to your 5 times table, 5 times 3 will give us 15. That means we'll multiply 3 also with the numerator, okay? So 3 times 3 will give us 9. 5 times 3 will give us 15. That means our answer here is 9. If you got this as your answer, then you are correct. Alright kids, so we have come to the end of our lesson for today. We looked at the second aspect of fraction, equivalent fractions. We said equivalent fractions are fractions of different numerators and denominators, but they represent the same value or proportion of the whole. They represent the same value or proportion of the whole. Now, how can we get equivalent fraction? By multiplication and by division. Now, number one rule is that when you're multiplying the numerator and denominator, you use the same number. And when you are dividing, make sure that the number you use to divide the numerator is the same number I used to divide the denominator, and there must not be any remainder. I hope you enjoyed today's lesson. Till we see in our next class. Thank you.